Hi all, welcome back to our YouTube channel. In this video, we are going to cover an important operator in cryptography, that is Modulo Operator. So let's get started. The Modulo Operator is one of the most common and extensively used operators in the world of cryptography. Before understanding the Modulo Operator, let's do the division of two numbers in the way we used to do in the school days. Consider the following example, which is 255 divided by 11. So let's perform the division operation. So we take 255 here and 11 on this side. Then we do 11 2s are 22. We subtract this, we get 3. Then we take the 5 down and then we do 11 3s are 33. And then we subtract this and we get 2. Since 2 is less than 11, we stop the operation here. Here 255 is called the dividend. Let's denote it by the letter A. 11 is called the divisor. Let's denote it by the letter B. 23 is the quotient, which is represented by the letter Q, and 2 is the remainder, which is represented by the letter R. Let's move the calculation to the side. So we have all this thing, that is A is 25, B is 11, Q is 23, and R is 2. So we can see that in division operation, we get 4 values. Now let's understand what is a modular operator. In cryptography, the modular operator is represented by mod. Now the equation is 225 mod 11. Let's understand the working of the mod operator. So the mod operator takes two inputs, that is A, the dividend, and B, the divisor, and it outputs R, that is the remainder. So we can see the modular operator requires three parameters, that is A, B, and R, and it doesn't use the Q. Also, R can take integer values in the range from 0 to B minus 1. In cryptography, such kind of range is represented by ZB, where B is a divisor. ZB represents a set of integers from 0 to B minus 1. Let's take the above example to simplify this mathematical notation. So we have A as 225, B as 11, and R as 2. Since B is 11, R can take the values from the range 0 to 11 minus 1, that is 10. And this is represented by Z11. So in a nutshell, we can say that the modular operator outputs the remainder of the division operation. So here the answer is 2. So here the answer of 225 mod 11 is 2. Although we can use our school techniques for finding the remainder, in cryptography numbers are not as simple as the example that was taken. Here the numbers are quite huge, and also in exams we have limited time to solve a numerical. And on top, scientific calculators are also allowed in engineering exam. So why not use them for a benefit, right? So now let's learn how to perform modular operation in scientific calculator. So let's derive the formula that is needed to find the remainder. So in school we learned the basic formula for division operation, that is dividend is equal to divisor into quotient plus remainder. Let's use the notation that we have used in the previous slide. So here A is equal to B into Q plus R. Let's take R on the LHS. So we have R is equal to A minus B into Q. Now let's shuffle B and Q. So the equation is R is equal to A minus Q into B. And now finally we have R is equal to A minus X into B, where X is equal to floor of A divided by B. Now I know that things are getting a bit complicated here, but be with me for the next couple of minutes and you will be master in modular operations. So consider a number line. Remember the thumb rule that in floor operator we always go to the left. Let's take some example to understand this. The first example is the floor of 0.5. Now 0.5 lies somewhere between this. So we go to the left, that is 0. So the floor of 0.5 is 0. The next example is the floor of 2.9. So 2.9 comes somewhere around here. So we go to the left, so it is 2. So floor of 2.9 is 2. Let's take some negative numbers. Let's have floor of minus 0.5. So 0.5 is somewhere around here and we go to the left, so it is minus 1. The next example is minus 1.5. So 1.5 comes here and we go to the left, so it is minus 2. Okay, so we have understood how the floor operator works. Just go to the left and fetch the first encountered integer. Cool. And that's it. We have the formula right here. That is R is equal to A minus X into B, where X is the floor of A by B. Now let's jump into some examples to be master in this. The first example is 1248 mod 123. So the first step is to calculate x, that is the floor of a by b, and the step 2 is to calculate the remainder, that is r is equal to a minus x into b. So let's calculate x. So here we have a scientific calculator. The model of this calculator is Casio 991 ES Plus, which is used by most engineering students in their exams. So we will be using the variables a, b and x so that they conform with the nomenclature that we are using. So let's input the first formula, that is a divided by b. We use the calculate button to input the values of a and b. So here the value of a is 1248. We press the equal to button after this, and the value of b is 123. Again we press the equal to button. So we get a fraction. To convert the fraction into decimal, we use the S to D button. So we can see the answer is 10.14634. Now we'll store the value of x as 10. Now we'll perform the second formula, that is a minus x into b. Now we press the calculate button. Here a is already filled with the previous input. Here x value is 10, so we input 10 and press the equal to button, and b is already there from the previous input. So we press the equal to button and then we get the remainder, that is 18. So we have calculated the remainder using the scientific calculator. So here r is equal to 18 and the answer to this question is 18. Let's take another example. Here the example is 2477 mod 89. The steps remain the same. Let's calculate the value of x using a scientific calculator. Another great feature of the calculator is that it preserves the history of calculation. So if we use the upper button, we get the previous formula, and if we click it once, we get the first formula. So let's calculate it. So here the new value of a is 2477 and the new value of b is 89. We have got this fraction, we convert it into a decimal, so the value of x here is 27. Now we use the second equation, that is a minus x into b. A is already there. We input the new value of x, that is 27, and b is again inputted in the previous operation. So we get the new value of r, that is 74. So here the remainder is 74. So the answer to the question is 74, that is 2477 mod 89 is 74. So we can see that after entering the formula, we can just use that formula again and again to find the modulo. We only need to be careful of the values that we are entering. Apart from that, everything is automated. Let's take a final and an interesting example. Here the example is minus 214 mod 126. Here you can observe that the a is negative. Just stick to the basics. All the steps remains the same irrespective of anything. So let's calculate x using the scientific calculator. So we again use the upper button twice to go to the first formula, that is a divided by b, and use the calculate button. Here the new value of a is minus 214 and the value of b is 126. We get a fraction that we convert into decimal. We are using the S to D button, and here we have the result, that is minus 1.69. So we have learned the floor operator always go to the left side. So if we go to the left of minus 1, we get minus 2. So here the value of x is minus 2. Now let's move to the next equation, that is a minus x into b. A is already present out there, and we input the new value of x, that is minus 2, and b is already out there from the previous input. So we have got the answer of 38, which is the remainder. So here r is equal to 38, and the answer of the question of minus 224 mod 126 is 38. That's the power of formula and proper use of calci. Within seconds we can calculate the modulus of any number. I hope you are now much more comfortable and confident in the modular operator after watching this video. In the next video, we'll continue to explore the different substitution ciphers, and we'll also cover solved examples using the technique that we have learned today. So that's it for the video guys. Thanks for watching the video, and if you have any doubt, please do let us know in the comment section below, and if you have found the video helpful, then do like and share the video with your friends and subscribe to Be The Best channel for more such videos. Meet you in the next video of the CSS series. Bye bye.